Alright, so today we're going to be talking about the distance formula. You should have already picked up a distance formula worksheet in the front of the room. Alright, you should have already made an attempt at warm-up number 1. How can Pythagoras help us find the distance between 2 points? How about between 2 locations? Okay, so I was looking for something about being able to draw that right triangle that we've been talking about and finding the horizontal distance between the 2 points and finding the vertical distance, and then we're able to use the Pythagorean theorem to find that diagonal distance. All right, warm-up number 2, I wanted you to find the distance between the stadium and the greenhouse. So what I would do is I would make my right triangle. I would have a distance of 3 here and a distance of 4 here. And then I would set up the Pythagorean theorem. 3 squared plus 4 squared equals c squared, okay? And c is our unknown. Okay, so we solve that and we end up with 9 plus 16 equals c squared. Okay, and we continue, we get 25 equals c squared, and then remember the last step is always to square root. So c ends up being the square root of 25, which we know is 5. So our distance from the greenhouse to the stadium ends up being 5. So c equals 5. Okay, we have a unit test coming up. These are all the topics that will be on it. So please take a minute and look through them. All right, so suppose we want to find the distance between the gas station and the art museum. Okay, your first step would be to draw in a line, right, from gas station to the art museum. So we'll call that distance D. Okay, you can be doing all of this on your worksheet that you picked up at the beginning of class. Okay, we can make D the hypotenuse of a right triangle. So just like we did in the warm-up, okay, how we made our right triangle, did the Pythagorean theorem. Okay, so the Pythagorean theorem says that for a right triangle, we know that a squared plus b squared equals c squared. Okay, and in this example, okay, we have coordinate points. We have it at 4, 4, and we have it at 6, 1. Okay, so our horizontal distance, okay, we have 2. Okay, and our vertical distance, we have 3 here. And I want you to recognize that our coordinate points can actually help us find those horizontal and vertical distance. So if we look here, we had 6 and 4 as our x values here. So 6 minus 4, that actually gave us our 2 value. We took 6 minus 4. And if we look at our y coordinates, we had a 1 and we had 4. If we subtract 4 minus 1, look at, we get 3 here. We get our y value. Okay, so yes, we could always go and count the spaces. Okay, but also be recognizing how we can use our coordinate points for those as well. Okay, so instead of saying 2 squared plus 3 squared, okay, we could put in our coordinate points instead. We could say 6 minus 4, our x values. We could subtract those. And then we could also subtract our y values to get us our 3. 4 minus 1. Okay, so just like we did with our slope formula, okay, how we labeled x1, y1, x2, y2, we're going to do the same thing with our distance formula. Okay, so we label one point x1, we label the other point x2, and then y1 and y2. Okay, so we're going to do the exact same thing. Okay, if we're given any 2 points, we're always going to label them x1, y1, x2, y2. And then we plug it in for our distance formula, which is written right here. Okay, so very similar to how we did our slope formula, how we labeled first, and then we just plugged the numbers into the correct spots. Okay, so please take a minute, write down the distance formula, okay, and we're going to go through a few more examples using the distance formula. Make sure that you also make a note in the distance formula sheet that distance is always going to be positive. So anytime that you're going to be asked to find the distance between 2 points, it will always be positive. You should never get a negative answer. Okay, if you get a negative answer, I would go back through and double check your work, okay, because you'd never say, I'm going to walk -2 miles to Caribou. Okay, you're always going to talk distance in positive 2 miles to Caribou. So make sure you are recognizing that. Okay, it's a common error that comes up. And on the MCA test formula sheet, you will be given the distance formula along with the Pythagorean theorem and other formulas. Okay, so distance formula is one that you need to know for the MCA test. Okay, so I want to try another example. Okay, we're going to find the distance between the stadium and the art museum. So the first thing that we need to do is we need to find our coordinate points. So if we look at the stadium is at -2 and up to a +3. So -2 and a +3. Okay, make sure you write this down kind of towards the bottom so you have a nice example to go off of. And the art museum is at +6, +1. So 6 for my x and 1 for my y. Okay, now take a minute and let's talk about how we came up with these steps for our distance formula. Okay, so remember, first things first is I would label our points, okay, x1, y1, okay, just because it's the first point that I see, okay. I could also label this one x1, y1, and this one x2, y2, but I just like to go in order. So here we have x2 and y2 for the 1 value, okay. And then all that we do is we write it down exactly like shown. We do our square root, okay, we plug in our parenthesis. My x2 value was my 6, so I'm going to plug in 6. And then I keep that negative sign that's there. And my x1 was a -2, so I put in -2 where x1 goes. Okay, end parenthesis, and I square it. Keep the same addition sign. Okay, all these addition and subtraction signs are important to make sure you keep them the same. Parenthesis. And then my y2 was 1, so I plugged in 1 there. Minus, because I keep that minus sign just like shown. And my y1 was 3. And then I square it. Okay, then the next step, how they got to step 3. Okay, they took 6 minus a -2. And if we remember, when we have a minus, a negative, we zoom. Okay, and that's how they get 8 here. 6 plus 2, they get 8. So they just did the inside parentheses, order of operations. And same thing for 1 minus 3. Okay, 1 minus 3, we get a -2. So they just did the parentheses. Okay, they did this parenthesis first to get 8, and then they did this parenthesis to get the -2. And then after that, we do our exponents. Okay, so 8 squared, we know is 64. Okay, and -2 squared, if you plug this into your calculator, okay, because it's not a negative, okay, a -2 times a -2, we get a +4. Okay, and then our last step is adding them together. 64 plus 4 together is 68. And we get the square root of 68, which ends up being approximately 8.2 if we're rounding to the nearest tenth. Okay, so please take a minute and make sure you write down all 5 of these steps here, okay, along with labeling your points. Okay, so make sure you have this entire example written on your sheet. Okay, now I want you to find the distance from City Hall to the animal shelter. Okay, and I want you to use the distance formula. So the first step is going to be to find your coordinate points. So City Hall is easy because it's at 0, 0. And the animal shelter is at 6 on the x and -2 on the y. Our next step is going to be to label our points x1, y1, x2, y2. And then we go into our distance formula and we start plugging in our numbers. Okay, so we write down our square root. My x2 value was 6, so I do 6 minus, because the minus sign, x1 was 0, parenthesis, squared. So all I'm doing is copying down my distance formula, plus, parenthesis, my y1, or excuse me, my y2 was -2, minus my y1, which was 0, end parenthesis, and squared. And now we just solve inside the parentheses first. Okay, so I rewrite my square root again. 6 minus 0 is 6. Keep my squared there, plus -2 minus 0, we get -2 squared. Okay, we get this 6 squared then. We do our squares. 6 squared is 36 plus -2 times a -2, we get a positive 4. So make sure you double check those into your calculator. Those negatives can sometimes trick us up. 36 plus 4, we get the square root of 40. And that's our final answer. Okay, if you want, you can plug it into your calculator. I want to do one last example with you on what if they don't give us a graph and we can't make our right triangles, which you could always do. That's always an option. Okay, I want to show you, well, what if you're just given 2 points? Okay, first we're going to label x1, y1, x2, y2. Okay, and exact same thing like we did before. Okay, we're going to take our square root. My x2 value was 4, minus my x1, which was 1, squared, plus my y2, which was 0, minus my y1, which was 4, and we square that. And then we solve inside the parentheses next. Okay, so our square root, 4 minus 1, we get a positive 3, plus 0 minus 4 is -4, squared. Okay, even though you should know how to subtract integers, okay, please make sure you double check sometimes into your calculator if you're double checking your work. Okay, and then we do 3 squared. 3 squared, 3 times 3 is 9, plus -4 times a -4 is a positive 16. 9 plus 16, what we get is 25, which we end up with just 5 for our answer. Okay, either the square root or the number is okay. Okay, so I want you to flip over your paper and I want you to work on the distance formula worksheet. Okay, when you're done, your teacher will have the answer key for you and you can go through your answers. And if you're still having questions or you're not sure about the distance formula, please make sure you're asking and we can walk through one of them together again. Okay?